Hi students, welcome to our YouTube channel Hayagreev Foundation. Myself Abhirami. Today I am going to explain about the topic electricity in physics. So what is mean by electricity? The word electricity, which is derived from Greek word electron, which means ampere. So what is mean by electric current? Electricity, we know it will plays very important role in our everyday life. Example, every electrical gadgets working with the help of electricity. In our house, we are using number of electrical appliances like TV, refrigerator, washing machine, whatever. So everything based on electricity only. So in electricity, we are using electric current. So generally, what is the meaning of current? So for example, in water or in river, water particles are moving, so that is called water current. Or in wind, air particles are moving, that is called air current. Likewise, in electricity or a conductor, that is like metallic conductor, the charged particles are moving. So charged particles are moving means that is nothing but electric current. So what is meant by conductor? So, okay, what is meant by conductor? So conductor is nothing but which is allow the passage of electric current or which is allow the passage of charges are called conductor. So next, insulator. What is insulator? Insulator is nothing but which does not allow the passage of electric current or called insulator. So in this conductor or metallic conductor, most of the metals like human body or all metals like aluminium, copper, iron, etc. all will conduct electricity. So insulators means which do not allow the passage of current. So that is example glass, rubber, dry wood, this do not allow the current. So that is called insulator. So in conductor, number of free electrons will be. These free electrons won't present in a particular place. It will move from one place to another place. So that is called free electrons. This free electron is responsible for conductivity. So these free electrons will start to move in one end of the conductor to another end of the conductor, which is called electron current. So all the electrons are moving from one end of the conductor to another end of the conductor, that is called electron current. Just opposite direction, all the positive charges will start to move. So that constitute electric current. So the electric current is the direction of positive charges. So now I am going to define electric current. So electric current is defined as rate at which charge flows. Rate at which charge flows or charges flow in unit time is called electric current. So electric current is represented by the symbol I, which is equal to Q divided by T. Q is nothing but charge, T is time taken. So the SI unit of charge is Coulomb, the SI unit of time is second. Then the SI unit of current is ampere. So ampere, when we are writing in word, we have to start with the small letter. If instead of small letter, we are using capital letter, that represents scientist name. So ampere symbol is A. So SI unit of current is 1 ampere. Now define 1 ampere. 1 ampere is nothing but 1 coulomb of charge flows in 1 second. Then the current is 1 ampere. So the device which is used to measure the current is a meter. So ammeter is a device which is used to measure the current. The device which we need to connect series to the circuit. Then we can measure the current easily by using ammeter. Now I am going to discuss about electric potential and electric potential difference. So what is mean by electric potential? So we are going to bring the charge from infinity to a particular point. We have to do work. That work is nothing but electric potential. So electric potential is nothing but work done to bringing unit positive charge from infinity to a particular point is nothing but electric potential. For example, if water in a horizontal tube, it does not flow. Why? Because two ends of the tube with the same level. If same level is there, water doesn't flow. If water is flowing from top of the tank to bottom, it is easily, because the water pressure is different in two levels. So that reason water is flowing from high pressure level to low pressure level. Like that, electric charges also moving from two ends of the conductor, means one should be at high potential, another should be at low potential. Then the charge carriers will flow always from high potential to low potential. Then in a conductor or two ends of the conductor want to maintain with a different level of potential, then the charge carriers will flow easily. So for main, current is flowing through the conductor. So two ends of the conductor want to maintain with a different level of potential. So two ends having potential difference. So what is mean by potential difference is nothing but the charges want to move from one point to another point. So we have to do work. That work is nothing but potential difference. So exact definition for potential difference is work done to moving a charge from one point to another point is nothing but potential difference. So potential difference is nothing but work divided by charge. So work, potential difference represented by the symbol V. Work W, charge is Q. So SI unit of potential difference is volt, symbol is capital V. Now the definition of 1 volt. 1 volt is nothing but 1 joule of work is to move the charge of 1 coulomb. 1 joule of work is used to move the charge of 1 coulomb is nothing but 1 volt. So the device which is used to measure the potential difference is voltmeter, which we need to connect parallel to the device. So ammeter you need to connect series to the circuit, voltmeter you need to connect parallel to the circuit. Then we can measure potential difference between two ends. Potential difference, work done divided by charge. So work done equal to Q into V. This formula we have to remember for further explanation. So next I am giving about the statement of Ohm's law. So very important topic, Ohm's law. Imagine this is a conductor. So current want to flow means, already I said, one end of the conductor want to maintain with high potential, another end of the conductor want to maintain with low potential. So current is flowing from high potential to low potential. Then potential difference across two ends of the conductor is directly proportional to current flowing through the conductor. This is Ohm's law. So potential difference across two ends of the conductor is directly proportional to current flowing through the conductor. Maintain temperature remains constant. So our temperature unchanged. So this is Ohm's law. Potential difference across any ends of the conductor is directly proportional to current flowing through this conductor. Maintain temperature is constant. So now V by I equal to constant. So this constant is nothing but resistance. So V by I is a constant. That constant is nothing but resistance, or SI unit of resistance is ohm. It is represented by the symbol ohm. That's it. So very important twisted model question they will ask from this topic. Factors depends resistance of the conductor. So first factor, resistance will depends length of the conductor. How does resistance depends length of the conductor? For example, we are taking 3 wires, each wires 1 meter 2 meter and 3 meter. So 1 meter is very short length. So charge carriers want to cross a small distance. So easily it will cross the conductor. If 2 meter means it want to travel for long distance. So some opposition will be. So resistance will increase. Again 3 meter means length still more increased. So resistance will increase. So length of the conductor increases. Resistance of the conductor also increases. So resistance of the conductor is directly proportional to length of the conductor. Length increases, resistance also increases. Next factor, area of cross section. We know if area will be very thin, the charges want to move in small area. If small area means some opposition will be. So easily the charge cannot pass through the thin wires. But if we are taking thick wires, the area of cross section will be more. So charge carriers can move easily. So area of cross section is more, resistance of the conductor will be less. So resistance of the conductor is inversely proportional to area of cross section of the conductor. So first factor, the resistance of the conductor depends is length of the conductor. If length of the conductor increases, resistance of the conductor also increases. One more thing, if area of cross section of the conductor increases, resistance of the conductor decreases. So only we are using inversely proportional. So third factor is nothing but nature of material of the conductor. For example, if we are using normally conducting wire made up of copper. Copper having low resistance, than that silver having low resistance. If silver cost is high, so we are not using silver as a conductor. But than copper, aluminium having little more conductor, comparable cost, we are using aluminium in postal wires. So thick aluminium we are using, reason thick aluminium wire will give less resistance. So it depends on nature of materials. We know silver having very low resistance. Next, copper having little more high resistance than silver, than that aluminium having little more high resistance, but iron having very high resistance. So that reason we are not using iron as a conductor. So three factors, the resistance of the conductor depends. One is length of the conductor, second one is area of cross section of the conductor, third one is nature of material of the conductor. Now how they are asking twisted model questions from this topic, let me see. As we know, radius over resistance of the conductor directly proportional to length of the conductor and inversely proportional to area of cross section of the conductor. So if proportionality means we can combine this equation by or directly proportional to L by A. So now in physics, proportionality we are going to change into equal sign. One constant want to multiply in right hand side of the equation. R equal to. So R equal to, the proportionality constant is rho. Rho L by A. Rho is nothing but resistivity of the conductor. Here both the resistance and resistivity of the conductor varies with the temperature of the conductor. If temperature of the conductor increases, both the resistivity and the resistance of the conductor decreases. They may ask one word question, how does resistivity or resistance of the conductor varies with the temperature? If resistivity or resistances increases by increase in temperature. So next, one more question I am asking. So how does, if length of the conductor increases, what about the resistance of the conductor? Or how does resistance of the conductor varies with the length of the conductor? Already I said resistance of the conductor increases by increasing length of the conductor. If length of the conductor is doubled, then resistance of the conductor also doubled. For example, R equal to rho L by A. So now if length of the conductor is going to double, R dash equal to rho into 2L by A. So 2 I am taking front, 2 into rho L by A. Rho L by A place nothing but what we can use means R. So what happens here? Length of the conductor is twice, resistance of the conductor also twice. Maybe length of the conductor is halved. Halved means reduces by 2. If length of the conductor is reduces by 2, resistance of the conductor also reduces by 2. Next factor, the resistance of the conductor is depends on area of cross section. So if area increases, resistance of the conductor going to decrease. If area is doubled, resistance of the conductor decreases by 2 times. If area is increased, area is decreased, resistance of the conductor increases by that many times. So now I am going to explain about a circuit diagram. Circuit diagram means it is nothing but the closed path of current in which number of components of electrical components we are using. So it is the closed path of current by which more electrical components we are using. So how we are using means in the form of their corresponding symbols. So now I am going to explain about some of the symbols we are using many electrical circuits. Now we are going to see the circuit symbols. First one, battery or a cell. So one long line, one short line. Long line indicates positive terminal and short line indicates negative terminal. Next, the combination of cells. So here I am drawing cells in series combination. As we know, positive terminal, negative terminal, again this cell positive, negative, positive, negative. So positive terminal of one cell connected to negative terminal of the another cell. So it indicates series combination of cells. So next, wire joint. Wire joint means 3 wires we have to use with a dot mark. So here 3 wires are joined. Next, wire crossing without joining means we have to draw over crossing that. So here 2 wires, one is moving upon the another wire. Both wires are not joining. So next, resistance. So this is the symbol of resistance. Next, variable resistance. One more name is rheostat. So rheostat, we can give resistance upside arrow mark or like this arrow mark we can give. So rheostat having total 3 connections. So 1, 2, 3 connections we are giving. So next, bulb. Next, ammeter having symbol A, one end is positive, another one end is negative. Like that, voltmeter symbol we are giving V, one end positive, another one end is negative. Next, plug key, open. Key means nothing but in circuit symbol, in electrical circuits, plug is nothing but key, or which one means switch. So plug key opened. So this one is plug key is closed. Closed means in between a dot mark want to give. So more and more devices still in higher studies you are going to learn all the electrical appliances or all the electrical devices we are using only the circuit symbol.
ನಾವು ಮಾಡ್ತಾ ಇರೋ ವಿಡಿಯೋಗಳು ನಿಮ್ಗೆ ಇಷ್ಟ ಆಗಿದ್ದಲ್ಲಿ ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ಪಕ್ಕದಲ್ಲಿರೋ ಬೆಲ್ ಐಕನ್ ಅನ್ನು ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ ನಾವು ಮಾಡೋ ವಿಡಿಯೋಗಳ ನೋಟಿಫಿಕೇಶನ್ ನಿಮಗೆ ಮೊದಲು ಬರ್ತದೆ. ಯಾವುದೇ ರೀತಿ ಸಂದೇಹಗಳಿದ್ರೆ ಕಮೆಂಟ್ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ತಿಳಿಸಿ. ಹಾಗೆ ಈ ತರಗತಿಗಳು ಹೆಚ್ಚಿನ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ತಲುಪುವಂತೆ ಶೇರ್ ಮಾಡಿ.